Hi, this is Mr. Adams from Midwood High School. This is a video on accuracy and precision. Accuracy and precision normally are used interchangeably in our lives in regular context, but when we get to chemistry and certain sciences, we want to specify the distinction between them. Accuracy simply means how close you are. Okay, so how close you are to the true value. Now, if we imagine, right, a target and you have a bullseye, and the bullseye is a true value. If you hit the bullseye, definitely, okay, you would have high accuracy. All right. Now, in terms of precision, now there's two flavors of it. Now, in A, precision simply means how well you can reproduce a certain value. For example, guys, when you go to college, for example, and you do certain experiments, when you take certain measurements, you want to reproduce that value. Now, it can be either good or bad in this sense. Because, for example, if you look at this guy right here, this second target, you're reproducing the points, yes, but you're away from the true value or the bullseye. So in this sense, even though you have high precision, high reproducibility, you have low accuracy because you're away from the true value or bullseye. All right. Now, in the third example, you notice, right, that you're neither accurate or precise. You're away from the true value, okay, or the bullseye. So that's low accuracy. And you're not reproducing, okay, your shots at a certain point, so that's low precision. So you're low in both cases. Now let's just say you want to weigh this gentleman over here, right? And let's say you get 450 pounds, 451 pounds, 450.1, and so on, right? That's high precision, okay, because you keep getting a reproducible close weight. But you will not be accurate. Your accuracy will be low because he definitely doesn't weigh 450 pounds. Okay, so we have to watch out for that and the distinction. Okay, moving on. The second way in which precision can be looked at is in terms of scales. Now we have two different scales right here, right? Two different rulers. Okay, one which I made up in the bottom. But here's the point. This scale in the bottom, right? We go from 3 to 4 to 5, right? And our smallest division is simply 1 by 1s. The scale in the top, you see 3 to 4, but it's divided into 10s in between them. So this particular scale in the bottom, if I put a point right here, let's say about here, right? And I had to say, okay, what is that point, or what is that arrow, what number is that arrow pointing to? I'm definitely sure about the 4, okay? So I know it's 4 points, but then I have to sort of kind of guess. I'm going to guess 4.6, or I'm going to guess 4.7, and so on, right? So I am unsure about the last digit right there. Now, in another video, we'll talk about significant figures. Now, in this particular case, both of these numbers, the 4 and the 6, they're called significant digits. The one you're sure about, and the last one which you're not sure about, okay? So in this particular case, we would have two significant digits right here, 4.6, or two significant digits for 4.7. We're sure about the 4. We're not sure about the 7. Okay, now in this particular scale at the top, right, if I put a mark right there, for example, right, I am sure about the 4. I can write 4 down. I am also sure about the 0.6, right? But I'm not quite sure after what happens after that. So I can say it's 4.61, it's 4.62. Now notice the difference between the two. In this one, I only got 4.6, right, up to the 10th place. In this particular scale up here, I'm sure about this, I'm sure about this, I'm not sure about the last digit. I can go to 3 significant digits. So you can say the more significant digit that you can write, more places, you can say this particular scale up here is more precise. And a scale, right, which has more divisions between them, more small divisions, will always have more precision in that sense. And a rule of thumb that we use, we said if they ask you, right, what's the precision of a certain scale, it's simply 1/10 of the smallest division. Here's what I mean by that. For example, this scale in the bottom, right? Let me use a different color. This scale in the bottom right here, okay, is going from 3 to 4, from 4 to 5. Its smallest division is 1, right? So if I took 1/10 of that, divide 1 divided by 10, I will get 0.1. What does that 0.1 mean? That's the precision of the scale. That means I can record my values, okay, the uncertainty of my values to the 10th place. So that's what that precision means when they ask you the precision of a scale. Now, in this particular scale at the top here is divided already into tenths, right? Into 0.1s, because each of these guys is 0.1. So that's the smallest division. Now, if I took 1/10 of 0.1 or divided it by 10, I would get 0.01. And what does 0.01 mean? That's the precision of the scale. It means I can record my precision up to 2 places, 2 decimal places, or to the hundredths place. Okay, so once again, that's how you figure out the precision of a scale if they ask you on a test or a quiz or something. 1/10 of the smallest division. Okay, guys, I hope this video was a help. Hard work plus sacrifice equals success. Study, study, study. Take care.